What if I told you? The largest object in our solar system after the Sun was never meant to be a planet. What if Jupiter was supposed to ignite, shine like a second sun, and completely change the fate of Earth? And what if the reason we exist today is because Jupiter failed? This isn't science fiction. This is one of the most unsettling truths in astronomy. Jupiter is not just a planet, it's a failed star. When we gaze upon Jupiter, we are met with a spectacle of cosmic artistry. We see its vibrant, swirling bands of clouds, a palette of oranges, whites, and browns painted across a colossal sphere. We witness storms larger than our entire planet, raging with an intensity that has lasted for centuries. And of course, there is that iconic Great Red Spot, a crimson eye, ancient and unblinking, staring back at us from the depths of space. It's a familiar, almost mythic image of the king of planets. But this mesmerizing facade is just the beginning. It's the thin, outermost layer of a world of unimaginable extremes. If we could plunge beneath these clouds, we would enter a realm where the laws of physics are pushed to their absolute limits. The pressure and temperature climb at a staggering rate, transforming familiar substances into exotic states of matter. What lies in the heart of this giant is a secret that scientists are still working to unravel, a place far more violent and strange than its beautiful exterior suggests. To understand Jupiter, we must first appreciate its sheer scale. Jupiter is massive. It is so incomprehensibly vast that it contains more than twice the mass of all the other planets, moons, asteroids, and comets in our solar system combined. If you were to gather everything else orbiting our Sun and merge it into a single object, it would still be less than half as heavy as Jupiter. This immense gravity has shaped our solar system, acting as both a guardian and a gatekeeper. And it's this incredible mass that brings us to a tantalizing question. What truly separates a planet, even a giant one like Jupiter, from a star? The answer lies in a cosmic battle between gravity and pressure. Stars are born from colossal clouds of gas and dust. As gravity pulls this material together, the core of the collapsing cloud gets hotter and denser. Eventually, the pressure and temperature become so extreme that the very atoms at its center begin to change. This is the moment of ignition. Nuclear fusion. Hydrogen atoms are crushed together so violently that they fuse to form helium, releasing a tremendous amount of energy in the process. This outward rush of energy is what we see as light and feel as heat. It's the engine that powers a star and makes it shine, pushing back against the relentless crush of gravity and establishing a delicate, lifelong equilibrium. Now consider Jupiter. It's made of the exact same raw materials as our Sun and countless other stars, primarily hydrogen and helium. It has the right ingredients. It has immense gravity. It possesses all the fundamental components of a star in waiting. So why isn't our night sky graced by a second, smaller sun? The difference, in the end, comes down to a simple, brutal fact. Jupiter just didn't grow big enough. It fell short of the critical mass needed to ignite its stellar fire. Astronomers have defined the thresholds for this cosmic transformation. The first significant milestone occurs at around 13 times the mass of Jupiter. At this point, an object becomes massive enough to start fusing not ordinary hydrogen, but a heavier isotope called deuterium. This process doesn't generate enough energy to make it a true star, but it does cause the object to glow faintly in infrared light. These objects occupy a fascinating middle ground, and they have a special name: brown dwarfs. They are often called failed stars. But even this title doesn't quite belong to Jupiter. Our solar system's giant, for all its might, is a lightweight in this cosmic category. It would need to be 13 times heavier just to begin the limited fusion of a brown dwarf. To become a true, long-lived, hydrogen-fusing star like our Sun, it would need to be even larger, about 75 to 80 times its current mass. Jupiter came heartbreakingly close, but the material in its corner of the early solar system simply ran out. It swept its orbit clean, growing into the behemoth we see today, but the stellar finish line remained forever out of reach. It is not a star. It is not even a failed star or a brown dwarf. It is something else entirely. The largest possible planet, an object pushed to the very brink of what a planet can be. A king, but not a god. A cosmic giant, forever denied a crown of fire. To truly understand Jupiter, we must journey to a place of unimaginable extremes, deep within its swirling atmosphere. Here, the laws of physics are pushed to their absolute limits. As we descend, the pressure builds relentlessly, reaching millions of times that of Earth's surface. Under this colossal weight, the most common element in the universe, hydrogen, is crushed into a state that defies our everyday experience. It becomes a liquid metal, metallic hydrogen, a vast, churning ocean of it, something we can only create for fleeting moments in specialized labs on Earth. This exotic substance is the engine of Jupiter's power. Its conductive nature generates the most powerful magnetic field in the solar system, a protective bubble that stretches millions of kilometers into space, dwarfing even the sun's own corona. This immense pressure, this exotic core, this isn't typical planetary behavior. This is the behavior of a star that never quite ignited. Jupiter is a world caught between two destinies. It possesses the same fundamental ingredients as our Sun, but it fell short of the critical mass needed for true stardom. So why didn't Jupiter become a star? The answer lies in a cosmic numbers game. To even begin the process of nuclear fusion and become a brown dwarf, Jupiter would have needed to gather about 13 times its current mass. To become a true, self-sustaining star like our Sun, it would have needed nearly 80 times its mass. It simply wasn't in the cards. The early solar system was a chaotic and competitive environment. The young Sun, in its T-Tauri phase, blasted the system with ferocious solar winds. This stellar gale ripped away the precious gas and dust from Jupiter's feeding zone. The raw material needed for growth was scattered to the cosmic winds. Time simply ran out. Jupiter's formation was cut short, its stellar ambitions permanently thwarted. It was left stranded, a king without a throne, forever a gas giant. Had it gathered that missing mass, our solar system would be a profoundly different and hostile place. A binary star system would have subjected Earth to gravitational chaos. Stable orbits would be a fantasy. Our planet might have been flung into the frozen depths of interstellar space, or sent on a collision course with one of its two suns. Life as we know it would have been impossible. But here is the profound twist in our cosmic story. Jupiter's failure to become a star is the very reason we are here to tell it. Its immense size, the very thing that marks it as a failed star, makes it our solar system's great protector. Its massive gravity acts as a cosmic shield, a celestial gatekeeper. We saw this firsthand in 1994 when the comet Shoemaker-Levy 9 was torn apart by Jupiter's gravity and slammed into its atmosphere. Each impact scar was larger than the Earth itself, a stark reminder of the violent forces Jupiter routinely absorbs on our behalf. Countless comets and asteroids, nudged from their distant orbits and sent hurtling towards the inner solar system, have been captured or redirected by Jupiter's gravitational embrace. It has sacrificed itself, over and over again, for billions of years, taking the impacts, absorbing the chaos, protecting a tiny blue world, allowing life to gain a foothold and flourish, often without us ever noticing the bullets it has dodged for us. That giant red storm on Jupiter, it's larger than Earth. It's been raging for centuries, and it's powered by internal heat, leftover energy from Jupiter's near-stellar birth. Jupiter radiates more heat than it receives from the Sun. Let that sink in. This planet is still cooling down from something it almost became. Imagine the nightmare, a second sun blazing in our sky. Orbit paths destabilized, Earth pulled into chaos, seasons destroyed, oceans boiled or frozen, life impossible. The solar system would not be recognizable. Jupiter didn't just fail, it saved everything. Jupiter doesn't just act like a star. In many ways, it behaves like one. It holds court over a vast and complex dominion, a system so intricate it resembles a miniature solar system of its own. We've confirmed over 95 moons orbiting this giant, a swirling collection of captured asteroids and fully formed worlds. But among them, 4 reign supreme: the Galilean moons, a royal court of cosmic possibilities. First, there is Io, the most volcanically active body in our entire solar system. Trapped in a gravitational tug-of-war between Jupiter and its sibling moons, Io is constantly squeezed and stretched. This relentless tidal flexing generates immense internal heat, turning the moon into a hellish landscape of fire and brimstone, with sulfurous volcanoes spewing plumes hundreds of kilometers into space. It is a world perpetually tearing itself apart and being reborn. Next is Europa, a world of profound mystery, wrapped in a shell of water ice. Beneath this frozen crust, evidence overwhelmingly points to a vast, global ocean of liquid salt water, an ocean that may contain more water than all of Earth's oceans combined. Jupiter's gravity provides the tidal energy to keep this hidden sea from freezing solid. Deep below, hydrothermal vents, much like those on Earth's ocean floors, could be releasing heat and chemical nutrients. It has all the ingredients we believe are necessary for life: water, chemistry, and energy. A place where life could exist, completely independent of the sun. Then there is Ganymede, the largest moon in the solar system, bigger even than the planet Mercury. It is a world of contrasts, with old, dark, cratered terrain alongside younger, brighter, grooved regions. Incredibly, Ganymede is the only moon known to generate its own magnetic field, a miniature magnetosphere nested inside Jupiter's colossal one. And finally, there is Callisto, the ancient, battered sibling. Its surface is the oldest and most heavily cratered in the solar system, a quiet, frozen record of billions of years of cosmic history. Jupiter didn't become a star, but it still creates and nurtures entire worlds, each a universe of possibilities. And in this fact lies an unsettling truth. Jupiter's story is a profound reminder of how fragile our own existence is. The universe operates on razor-thin margins. One small difference in the initial cloud of gas and dust, a slightly different accumulation of mass, one different moment in the timeline of our solar system, and the entire story would have been rewritten. If Jupiter had gathered enough material to ignite, even as a dim brown dwarf, the resulting gravitational chaos and radiation would have prevented the stable, life-giving system we know. There would be no Earth, no blue oceans, no breathable air, no history, no art, no science, no love, no us. Our entire existence is balanced on the knife's edge of Jupiter's failure to become a star. And so Jupiter sits there silently in the dark, a monument to a path the universe almost took, and a testament to the path it gave to us instead. So the next time you look up and see that brilliant, unwavering point of light in the night sky, remember what you are truly witnessing. You're not just looking at a planet. You are looking at a star that never ignited, a cosmic guardian that sculpted our solar system and protected us from harm without ever asking for credit. And the silent, magnificent reason the universe gave us a chance to be here. Now, looking back at it, Jupiter didn't shine so that we could.